All right, so we've already talked about ionic and covalent bonding a little bit, and so we've really touched up on ionic bonding. So part two of the notes, and so I want you to go ahead and add these onto your ionic and covalent bonding from last week, but we're going to go ahead and do covalent bonding. Okay, and so just to reiterate, okay, the reason things bond is to become stable. Okay, and an atom is only stable if it has a full valence shell. And so this is just a review. An atom is stable, it will not bond. And if an atom is not full or it's not stable, it will bond. Okay, so just to reiterate, energy level 1 can only hold 2 valence electrons. Energy level 2 will hold 8. Energy level 3 will hold 8. And then we also follow those octet rules for energy level 4, 5, 6, and 7 if we have elements in that. Okay, and so once again, compounds are formed when two atoms of different elements bond together. Okay, and so atoms will bond to fill their valence shells. An atom will bond with as many atoms as it takes to fill that outer shell. Okay, and so this is all just a little bit of a review. So we went ahead and talked about the two types of bonding. We talked about ionic bonding, and today we're going to be hitting on covalent bonding. And so we talked about ionic bonding and how it is a metal versus a non-metal. Okay, and so this is crucial here, being able to determine between ionic and covalent. So this is just a little review. Okay, and so part of your job is to differentiate between ionic and covalent, being able to tell the difference between ionic and covalent. And so how we know it's ionic is when it's a non-metal bonded with a metal. Okay, and so the big point here, and so you need to circle this, highlight it, star it if you have it written down. If you haven't, write it down. Okay, it's when two atoms bond by either gaining or losing electrons. So they're stealing or they're giving. Okay, and in doing so, they become ions, and those atoms are attracted due to their charge. So think like a magnet. A positive is attracted to a negative. Well, when an atom loses an electron, it becomes positive because it's losing a negative particle. When it gains an electron, it becomes negative because it's gaining a negative particle. Okay, and so those atoms will be attracted due to their charge when they gain or lose electrons. Okay, and so once again, we use the periodic table as a tool. And if you haven't colored your periodic table, please do so because this will make your life so easy. Okay, so we have our metals and non-metals. So it's ionic when something in yellow is something bonded with something in purple. All right, and so I've given you examples of ionic compounds, and so you should have these in your notes already. Okay, it's when a metal is always bonding with a non-metal. Okay, and so if we look on the periodic table, sodium is in the yellow, chlorine is in the purple, and these will all follow the same pattern. Okay, so notice the metal always comes first in ionic. And so this is all review. So what we're going to be talking about today, and so you need to add these into your notes, is we're going to be talking about covalent bonds. Okay, and so a covalent bond exists when a non-metal bonds with another non-metal. Okay, and so this is an important slide here. Okay, and so the difference is covalent bonds actually share electrons. Okay, so ionic, one is losing and one is stealing an electron. So they're actually stealing and losing. So in turn, ionic, they're becoming positive and negative. Okay, well, covalent is not stealing or gaining. It's sharing those electrons. Okay, and so you'll see that here when we draw covalent bonds. Okay, so shared electrons do not belong to either atom. They actually orbit both atoms. Okay, so some examples of a covalent bond would be H2. Okay, it's a non-metal and a non-metal, and notice there's two hydrogens. So hydrogen 1 and hydrogen 2 would both be a non-metal bonded. You have water, which is H2O. Okay, the hydrogen is non-metal, the oxygen is non-metal. And how do we know? Because look, hydrogen's purple, oxygen's purple. They're both non-metals. Okay, and so you guys can see in the other examples, NO3, non-metal, non-metal. CH4, once again, carbon is a non-metal, hydrogen is a non-metal. Okay, and so this is the big difference between ionic and covalent. Ionic, you would see a metal with a non-metal. Covalent, you should know it's a non-metal and a non-metal. Okay, that is the easiest way to distinguish if it's covalent or if it's ionic. All right. So let's go ahead and make some covalent compounds. Well, once again, we're doing the same thing almost. Okay, so just pay attention. Okay, and then at the end of this, go ahead and copy what I've wrote. So I'm going to go ahead and write hydrogen and fluorine. Okay, and then once again, I'm going to draw their Lewis dots. So hydrogen's in group 1, so it has 1 valence electron, and once again, hydrogen is here. Okay, and I'm going to draw that H. Hydrogen's here. We just have it out there just so you guys know it's also a nonmetal. Okay, and it has 1 valence electron. Well, fluorine has 7 valence electrons because it's in group 7. Okay, so we're going to go ahead and put 1, 2, 3, 4, 5, 6, 7. Now, we have to look at where these electrons are going to bond. Well, before, we used to just show who was stealing and who was gaining, so we drew arrows. Well, that is not the case, okay? We actually have to look at these atoms as if where are they going to bond, all right? And so this has a lone pair here, and this has a lone pair here. Well, they're going to want to share each one of those lone pairs. And so I'm going to go ahead and circle the pair that's going to be shared, okay? Now, this is not how we draw it, okay? And so what ends up happening is hydrogen and fluorine, okay? So once again, we're going to be using its lone pairs. Now, I'm going to put hydrogen's electron here just because it will be closer to fluorine. It's easier to draw, okay? And fluorine's lone pair is also going to be closer to hydrogen. Well, they want to share these electrons. And so what we do is we actually show a bond here. Okay, and so we draw it with a line that's showing they're sharing these electrons. And so each line is going to equal two electrons, which are negative. Okay, so every time you see a line that's bonded, it's showing 2 electrons. Okay, and so now we have to look at each atom. Well, if we look at hydrogen, hydrogen's in that first shell. Okay, so it only needs 2. And technically, because it has a line next to it, it has 2 electrons. Okay, and so if we look at fluorine, fluorine needs 8 valence electrons. So it has 2 here, it has 2 here, it has 2 here, and it also has a line on it as well. It has a bond. This is showing a single bond. So technically, this is a 2 as well. So it's 2, 4, 6, 8. So that just goes to show that each atom is satisfied. Okay, and so this would be how we draw a covalent bond. It's actually bonding. Okay, where in ionic, we were actually showing the distribution. Okay, these are not distributing. It's not giving or taking. It's sharing them. Okay, so looking at another covalent bond, let's go ahead and do hydrogen and oxygen. Okay. Now, we're going to go ahead and put the hydrogen's lone pair on the right side just because it's going to be closer to oxygen, so it makes things easier. And so I have 2 here. Okay. 2, well, I have 6 valence electrons because if we look at group 6, it's in group 6. Okay, 6 valence electron. Hydrogen, we just talked about, it's in group 1. Well, hydrogen is going to want to go ahead and bond these 2. But the problem is we see oxygen has another lone pair. So just like we did in covalent, we add another hydrogen. Okay. We're going to go ahead and add another hydrogen. So once again, adding its electrons. Well, now hydrogen is also going to want to share this lone pair. Okay, and so the way we write this is we show oxygen with 6 valence electrons. And now I'm going to organize hydrogen and oxygen so they fit, okay? And so you're going to notice what I do is I'm going to put a hydrogen on the left side. I'm going to put a hydrogen on the left side, okay? And then I'm going to go ahead and show its valence electron here. And then I'm going to put a hydrogen at the bottom. And I'm going to put its valence electron on top, just because I want to put those lone pairs as close as I can so I can show these bonds. So each of these lone pairs and each of these lone pairs are next to each other. Okay, and so oxygen and hydrogen are actually going to share these. Okay, and so oxygen and hydrogen are also going to share this. Okay, and so if we look at hydrogen, each hydrogen satisfied, because remember, okay, each bond is showing 2 electrons. And remember, hydrogen is in that first shell, so it only needs 2. So this hydrogen is satisfied. Okay, if we look at this hydrogen, it also has a bond. So that shows 2 electrons. It's satisfied. Well, now let's look at oxygen. Oxygen is in the second shell, so it needs 8 valence electrons. So it has a lone pair here. It has a lone pair of electrons here. And then it has 2 bonds to 2 different hydrogens. So that's 2, 4, 6, 8 electrons. So hydrogen is also satisfied. So technically, this is water. Okay, and so this is what I would be expecting you guys to draw. Okay, and so they're sharing electrons. So let's go ahead and do oxygen and oxygen. Okay, and so I'm going to go ahead and once again, I'm going to draw the Lewis dots to where the lone pairs are closest together. Okay, and so on this one, you guys would draw the lone pair or the valence electrons 1, 2, 3, 4. That's awesome. Okay, 5, 6. So notice the lone pairs are closest to this oxygen. So once again, 1, 2, 3, 4. But in this case, I'm going to put the lone pairs on the opposite side. Okay, they still show valence electrons of 6 each. Okay, but I just put them closest together so you guys can see and you guys can write it easier. Well, each one of these lone pairs want to be together. Okay, so oxygen is actually going to share these electrons and they're going to form a bond. And they're also going to share these electrons and form a bond. Okay? And so the question is how do you draw this? Well, once again, we know it's going to have 2 bonds together or 2 lines. And so the easiest way to draw this is I'm going to go ahead and put oxygen, and I'm going to put oxygen. Now, we know that these 2 pairs are going to make a bond, so I'm going to go ahead and draw this bond. So I've gone ahead and drawn this bond. Now I'm going to show this bond. And so these oxygens are actually going to have a double bond. Okay, and so I've now shown both bonds. Okay, and so once again, each oxygen needs 8 valence electrons, so I have to carry down its valence electrons. So I'm going to put the rest of its valence electrons right here. Okay, and so we can see the oxygens are sharing a total of 4 electrons, because remember, each line is 2 electrons. Okay, so it has 2 bonds, and then each of them have 4 electrons by themselves. So if we count, for this oxygen, we have 2, 4, and each line is 2, so 6, 8. So this oxygen is happy. And then also this oxygen, we have 2, 4, 6, 8. So each oxygen is satisfied. And so this would be my covalent compound for oxygen. And so how we would write this would be O, and how many do we have? 2. This is going to be O2, and this is actually the molecule that we breathe. Okay, and so this is the oxygen that is essential to life. Okay, so let's go ahead and do one more. So we have nitrogen and chlorine. Okay, so I'm going to go ahead and draw nitrogen, and I'm going to draw chlorine. Okay, and so once again, nitrogen, if we look, nitrogen is in group 5, chlorine is in group 7, so nitrogen has 5 valence electrons, chlorine has 7. So we're going to go ahead and draw 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Okay, and so we're looking at lone pairs. Well, if we go ahead and look, nitrogen and chlorine are going to share these electrons. Okay, so if we look, chlorine is actually going to be satisfied because once we put a line between these, it's going to have 2, 4, 6, 8. Problem is nitrogen is not happy. It still needs to share this electron and this electron. So notice how I go ahead and add the chlorines to make drawing this easier. You don't have to keep them on one side. And so I'm going to go ahead and make chlorine with 7 valence electron, but notice what I do with my electrons. I put them in a place where it's easy to show the sharing of electrons. So I've gone ahead and put the lone pair on the right side this time to match up with nitrogen easier. So nitrogen and chlorine is going to share this electrons, okay? And then I'm going to go ahead and nitrogen's still not happy. It needs to also bond with a chlorine down at the bottom. So I'm going to add another chlorine, okay? And so once again, I'm going to go ahead and draw my valence electrons. Now notice chlorine still has 7, but I'm going to show its lone pair up top this time to make it easy to draw, okay? And so it also is going to share these electrons. Okay. And so when I draw these, I'm going to show them as bonds. So everything that you see is a circle. So I'm going to go ahead and draw nitrogen. Well, I already know nitrogen's going to have 3 bonds. Okay. It's going to bond to something. It's going to bond to a chlorine to the left. It's going to bond to the chlorine to the right. And it's going to bond with the chlorine to the bottom. Okay. And so I'm going to go ahead and add those chlorines. Okay. And so what I've gone ahead and done is I've just gone ahead and made the bonds that are showing here. And so you can see those lines to the right. Okay, I have 1, 2, 3 bonds, okay, to 3 different chlorines. But what I need to add is the rest of the electrons. So chlorine has 6 electrons or 3 pairs of electrons. Okay, and so I'm going to go ahead and show that. So this chlorine has its lone pairs. This chlorine also has 3 pairs of electrons. This chlorine over here also has 3 electrons. And this nitrogen has 1 pair of electrons. Okay, and so if I go ahead and check each element, okay, chlorine needs 8 valence electrons. Okay, and so it has 2, 4, 6, 8. Chlorine is satisfied. Nitrogen has 2, 4, 6, 8. It is also satisfied. This chlorine has 2, 4, 6, 8. It is happy. And this chlorine down here has 2, 4, 6, 8. So every element has filled its octet. And so technically all of the atoms are satisfied. Okay, and so this would be my molecule and how I draw a covalent compound. And so you're going to be using these, okay, for drawing covalent compounds. And now you have to understand the difference, okay? And we're going to be starting to differentiate the difference between ionic and covalent. Okay, and so for ionic, we draw the arrows, okay, showing the transfer of electrons. And then in covalent, we draw lines that are showing the sharing of electrons. Okay, so go ahead, make sure you're writing these notes down with the examples. Okay, Mr. Sasfi, me will be checking your notes when you guys get back if you are at home taking these notes. And in class, Mr. Sasfi will be checking tomorrow to check your notes.